Pokémon TCG is a game of decision making, where every small decision can impact your chances of winning. Well, today we're going to be looking at how deck thinning strategies can help you improve your chances of winning. Let's get to it. Welcome to episode 7 of Pokémath. My name is Stefan Eriksson, and today we're going to be looking at the impact of deck thinning. So, to tell you what it's about, well, first let's look at the motivation for today's episode, shall we? We are going to look at how the act of deck thinning, that is, getting rid of cards you don't need in order to win, to actually improve your chance of winning. That's a very bold statement, so let's look a little more into it, shall we? First of all, what is deck thinning exactly? Well, I just gave you a small notice, but let's just put it on the board, shall we? It is essentially cards that are used to reduce the size of your deck, which thereby increases your chances of drawing what you need in order to win the game. And we've all been playing the game and had these situations where if I just hit this one card, then I will win the game. And then, some stories we hear that you hit it, yay. Other times, not so much. So we're going to be looking at what you can actually do to have more of these scenarios where you'd be like, yes, I hit it and I win the game because of it. Well, what is it in Pokemon? Deck thinning is not really that. Like I said, playing cards down, like stadiums, play a basic down, play a switch, play an energy switch, play any different items, trainers, supporters even, or energy cards down that will help reducing your deck size so that for next time you have to draw, it will increase your chance of drawing what you actually need. Well, this is also very much related to sequencing, which then relates to playing cards in the correct order to improve your chance of winning. That's not so much what we're looking at today, but deck thinning and sequencing goes very well together. They're very closely related to one another. So the things I look at here today can also directly be used for sequencing. Maybe I should make a video about that sometime, but let me know if I should. But for today, we're going to be sticking to deck thinning. Okay, so how are we going to do it? Hypergeometric distribution, of course, which is what we've been using for countless number of episodes. Well, you can just go back to episode 1 to get the full explanation of how this works. But basically, we're dividing our deck into two pieces, successes and failures. Successes being hitting our outs and calculating the chance of hitting these outs. And the other part of the deck being, well, not outs, so things that we do not need. In this particular case today, we're going to be using an example where, well, you probably have this one before. You're just drawn 2 prizes, you're down to 1 prize, you know that your opponent is going to reset stamp you, so he's going to stamp you to 1. In this particular case today, we need to draw just one of our 4 remaining energy cards to win. Well, let's visualize this a bit. That will also help explaining this here. So we get stamped. That's bad. Well, it's not the end of the world, but it's pretty bad. But what can we then do to kind of protect ourselves against stamps? Look at this field here. This is a practice game or just a scenario I set up for you. We're playing a not so interesting Pika Roam deck, post-rotation. And in this case here, you are about just to take a knockout using Tack Bolt. Nope, you cannot do the full blitz. You need to hit the 200 damage in order to take this knockout. When taking this knockout here, you will draw 2 of your 3 remaining prizes. Your hand size will then grow to 12 cards. You currently have 10. And then you know that the next turn, your opponent is going to stamp you. And in order to win this game, you need to draw one of your remaining 4 lightning energy cards that is left in that deck depicted there. You have already tested energy for turn, so those 2 cards we cannot play. And now we have to look into, well, given how many of the other cards we play down, how would that impact our chance of winning? So to put it short, let's see what the impact is by playing as many cards as we can from this hand and see what it does to our chance of winning. Remember, we can't play energy, we already placed our energy, and we're just about to attack, so we can of course just still play all the cards we need to get rid of. But let's see what happens. So let's establish a benchmark. Do nothing. That is, we are just ignorant and we don't play any of the cards down whatsoever. What is your chance of hitting 1 of your outs next turn? So here you have to remember a thing. You're getting stamped to 1, that means you draw 1 card from the stamp. but in fact you actually get 2 cards because you also get to draw your card for your turn. And therefore, we can just put it the following way using the hypergeometric distribution. So I'm doing 1 minus the chance of not hitting it, which then gives the chance of actually hitting it, right? So the way I'm computing this here is that we have 4 over 0. So we have 4 copies of Lightning Energy in deck. We are doing 1 minus not hitting it. And then of course 18 minus 4 over 2 minus 0 is what we have explained so many times before. Please watch episode 1 if you want another explanation for this. Or the previous episode 6 also does it in a multivariate sense to explain how this actually works. But using this formula, which can be easily implemented via Excel, then you can get that our chance of actually winning next turn by hitting one of our energy cards, by drawing 2 cards from our decks, is 40.52%. So give or take 2 out of 5. That is not terrible, but let's see what happens as we start playing down our cards. So first, let's deck fin 1 card. Suppose we play one of our basics from this hand that I showed you before down to our deck. That could be the 6 Sagoon, for instance. This is the same as reducing the deck size by 1, because now that card will not go back into the deck when your opponent reset stamps you. So therefore, we are essentially just making the same calculation but with the deck size minus 1. That will go the following way. And now we see that the increase has been up to 42.65%, which increases by 2.13% just by playing 1 card. It doesn't look like much. Well, 2% is something, but it doesn't look like too much. So how can we actually do this now? Well, let's look at the opposite end of the spectrum. That is, we play all possible cards that we can from our hand. So from the hand I've given you here, we can actually play every single card except the 2 energies because we already attached. That means we're actually reducing our deck size by 8 because we're playing 8 out of 10 cards from our hand. In other words, we're just playing down the net, we're playing down the net to take up the 6 Dragoon, we're playing down the Mars Shadow, we're playing down the Energy Switch to switch, net up, whatever. We're playing all these cards from our hand in order to improve our chance of winning before we attack with Tack Ball to take our 2 prizes. And it should also be said here, we know that 2 of the prizes we draw there do not contain energies. We know that everything is in our deck because we counted on an earlier search. But what actually happens now? Well, we see that the chances of actually winning now by drawing 1 of your energies will increase to, well, 2/3. That sounds a whole lot better than 2 out of 5. Now we can do it 2 out of 3 times. And that already, this here simple example here, but it comes in many flavors and many, well, twists and turns. This here shows, for instance, how you can actually improve your chance of winning just by deck finning. Like, we heard it so many times before, and yes, I know this seems a little simple, but it's good for people to see it on screen, quantified how this actually works. I can actually also generalize this for you, showing in the following way. This is the table I made for this example here, and you can then vary the number of outs versus your deck size, and the Excel sheet I've made, you can also just twist and toggle all these different inputs to get the probabilities. If you want me to release such a thing, just let me know, then I will put a link for it in the description below. But let me know first, because I don't know whether this is worth putting out, but tell me, I'll be happy to oblige. So for this particular case, look at the row for 4. That is exactly what we used in this example. We started out by not doing anything, and then by, well, maximizing our odds, in this case here, the probability of winning, we move it all the way over to the other end of the row, thereby going from roughly 2 out of 5 to 2 out of 3, which is a lot better, which is an overall improvement of 26.15%. So what is the take-home message here? Well, we can use this hypergeometric distribution to calculate, well, the effect of finning your deck, and then we can also extend this to the effect of, well, good sequencing. What is the impact of playing cards correctly in order to improve our chances of winning? I did not look at sequencing today, I just gave you how it works for deck finning, but maybe I'll return back in another video. But for today, I hope you got something out of this today here, and please let me know in the comments below if you liked anything what you saw today. Until next time. Hey guys, thanks for watching today's video. If you like what you saw, then please don't forget to like, comment, subscribe, because we need to beat that algorithm I heard. I'm still new to this, so still getting to use all the YouTube stuff here, but I hope you like it so far, and well, I'll be happy to hear your input. And otherwise, until next time.